Good morning, student. Good morning. So today we discuss one simple concept. So electromagnetic induction. The electromagnetic induction is the basic principle of production of the current, electric current. So what is an electromagnetic induction? The electromagnetic induction, varying magnetic field produces EMF. EMF means electromotive force. So now we do the experiment for the electromagnetic induction, how the electromotive force produces in the coil. So this is a magnet. The magnet, in this magnet, the electromotive forces, the lines of forces, magnetic lines of forces around the magnet. Around the magnet, we can't see the magnetic field or magnetic lines of forces around the magnet. And this is a north pole, this is south pole. The magnetic lines of forces inside the magnet. Inside the magnet, the lines of forces goes from the south to north. Outside the magnet, the lines goes to north to south. So the electromagnetic loop is a closed loop, not a single line, is a closed loop. The moving magnet, so now, so this is a galvanometer. Galvanometer is a measure of the current, measuring of the current. The instrument is used to the measure of the current. So now this is a magnet. Here we insert near the coil. Near the coil, it is a stable both of the coil and the magnet. So no deflection in the galvanometer. So now we move the magnet. We see that move the magnet, the deflection will be created in the galvanometer. So what is the deflection from this? The magnetic field produces the electromotive force in the coil. In the coil, the electromotive force is called the simplest current. Simplest current. This is a basic principle, the production of electricity. Production of electricity. So we use this principle. The large amount of current will be produced in the power plant, atomic power plant and water plant, and then air, from the air. So okay, this theory is invented before 600 years. That's the Michael Faraday discovered this experiment. Okay, are you understand any doubt? You ask me, I clarify you. Okay. Good morning. I am Nagarajan, Department of Physics. So today classes we discuss about the electromagnetic inductions. So electromagnetic induction. So electromagnetic induction means the electromagnetic induction is the process of using magnetic field to produce voltage and in a complete circuit current. Michael Faraday first discovered it using some of the works of Hans Christian Weierstrass. His work started at first using the different combination of wires and magnetic strength and currents. But it wasn't until he tried to moving the wires that he got any success. So then we know first about what is a magnetic field. So magnetic field means the magnetic field is the region around the magnet material, around the magnetic materials like this. So are a moving electric charge within which the force of magnetism act. So this is for example, this is a bar magnet. Bar magnet, this is a north pole, this is a south pole. We can't see the magnetic field or magnetic lines of forces, they our normal eyes. For example of current, electricity, we can't see the electricity, but we feel, touch the current. So same as the magnetic field, the lines of forces around the magnet or the current carrying conductor, we see the next. So this is a bar magnet like this. The lines of forces outside the magnet north to south. and the inside the magnet south to north. So this is the magnetic lines of forces, a closed loop, not a single line. It will be always a closed loop, always the closed loop electromagnetic induction. So almost 200 years ago, Faraday looked for a evidence that a magnetic field would induce an electric current with this apparatus. So like this. So this is the electromagnetic induction produces in the coil. See that the first one not moving the magnet, the electromotive force, like that EMF does not produce, but in the moving the magnet, electromotive force produces in the coil. It goes to the galvanometer and the deflection will be credited in the galvanometer. So he found no evidence when the magnet was steady. This is an important one. He found no evidence when the magnet was steady. Then the magnet will be moved, the electromotive forces created. So but did see a current induced when the magnetic move up and down. From this figure, the magnet when the stable, electromotive forces does not produce, magnet will move up and down, the deflection will be created in the galvanometer. So what is an electromagnetic induction? Faraday's law. In order to understand Faraday's law, we need to understand the concept of magnetic flux. First we know that the magnetic flux. What is a magnetic flux? So what is a magnetic flux? Magnetic flux is defined as the number of magnetic field line passing through a given closed surface. This is one important. Magnetic flux is defined as the number of magnetic field lines passing through a given closed surface. It provides the measurement of the total magnetic field that passes through a given surface of area. Here the area under the consideration can be of any size, under any orientation with respect. So this is how the electricity works. So this is a basic principle of the electromagnetic induction, and then we use this principle, we produce the electricity and the large amount of 1000 volt and 2000 volt and etc. So this is a principle of how electricity works. Electromagnetic induction pass a magnet field through a coil will induce a voltage and current. Magnet, this is, and in the green color the coil. The green color is the coil, and in the middle of the coil the magnet will be moved. The lines of forces already we discussed about the lines of forces, that is a magnetic field around the magnet in the closed loop only. We see it in the blue color. This is called the closed loop of the magnetic lines of forces, and the magnet will be moving the lines of forces created. So next. So okay, now we see that the electromagnetic induction. First we know that about the magnetic flux. What is a magnetic flux? Magnetic flux is the quantity of magnetic field. That penetrate an area at a right angle to it. So what is electromagnetic induction? Electromagnetic induction refer to the generation of electric current by passing a metal wire through a magnetic field. Electromagnetic or magnetic induction is the production of electromotive force like EMF. We tell about shortly EMF. EMF means electromotive force across an electrical conductor in a changing magnetic field. We see that image of the below of this slide. The electromagnet or magnetic induction is the production of an electromotive force across electrical conductor in a changing magnetic field. Here the magnetic field will be changed because of the magnet will be moving. The magnetic field will be changed. And then when an induced current is produced because of voltage production due to the changing of magnetic field, it is called the electromagnetic induction. So electromagnetic induction will be produced when the magnetic field will be changed, or the magnetic field at a stable and the electric field the coil or changes. So the any one changes because of the when the magnet is stable, the coil from the distance the magnet changes, distance changes from this magnet, the EMF will be produced. Next, brief history of electromagnetic induction. In 1820, Weierstrass first discovered that magnetic field is always associated with an electric current. Simply we know that the magnet our earth is a perfectly magnet. So the magnetic lines are inside the earth, and the lines of forces goes from the south to north, and the outside of the earth the lines goes from the north to south, the closed loop. In 1831, August 29, Faraday discovered electromagnetic induction by famous induction ring experiment. The electromagnetic induction test, they make a connection between the galvanometer and the copper coil with the electric wires. Try to push the bar inside the coil, take away the bar from the coil. So three images we see that. The first one the magnet make a connection between the galvanometer and the copper coil, the electric wires. And second one, try to push the bar inside the coil, inside the coil. And the last one is take away the bar, magnetic bar from the coil. So characteristics of electromagnetic induction. For moments between magnetic bar and the conductor, there will be a deflection in the galvanometer because of the production of electromotive force. If the bar and the conductor remain steady, then there will be no deflection in the galvanometer. So galvanometer, what is a galvanometer? Galvanometer is the measuring instrument of current measuring instrument. So the deflection will be created in the galvanometer, there will be created in the current. So in the second, the bar and the conductor remains steady, there will be no deflection in the galvanometer. So the current will not be produced. If the pole of the magnetic bar is changed, so already we know that the south pole and the north pole, if the pole of the magnet bar is changed, the direction of the induced current will be changed. So now we insert the magnet within the coil, the deflection from right to left. Then we change the pole, north pole, insert the coil, the deflection will be in the opposite side to the south pole. So when the loop in the coil increases, the deflection become greater, and when loops decreases, the deflection becomes smaller. So Faraday's experiment of electromagnetic induction, Faraday conducted 3 different experiments to find electromagnetic induction. He used the coil of wire, galvanometer, and a bar of magnet. By nothing deflection he conducted is a first experiment. So Faraday experiment of electromagnetic induction, he replaced the magnet bar with a current carrying solenoid to perform his second experiment. So first experiment we use the magnet, and second experiment we not use the magnet. For this, instead of magnet, they replaced the magnet bar with the current carrying solenoid to perform his second experiment. So other one, he placed 2 coils close together face to face, but the rest with respect to each other, and by closing and opening the circuit, he conducted his third experiment. So this is a demo of the Faraday's law of electromagnetic inductions. It's okay. So some of application of EMI. Some of the applications, electromagnetic induction. So first one is induction sealing, induction motors, and electrical generator, transformers, induction welding. We know that the best example of cycle dynamo. In the previous years we use the cycle dynamo. In the cycle dynamo, magnet this is stable. The coil around the magnet, we move the bicycle, the wheel rotate, then the coil also rotate, then the electricity produced, the bulb will be glow. So then after some of the application of electromagnetic induction, the magnetic flow meters, and then graphic tablet, wireless energy transfer, audio and video tabs, electric gator pickups. So okay, thank you.